What's all the rage in the media right now, man? Seed oils.
Oh, yes, Lord. Man, I had this huge conversation with somebody just the other day. Wow.
Seed oil,
Take us
seed
in there,
oils.
brother. Take us
Yeah,
in.
so we're going to spend the
Canola.
next,
Canola.
you know, we're going to spend the next few weeks getting into seed oils, and we're going to look at all the famous, old, obscure trials that everybody online likes to tout as being evidence that seed oils are harmful for you, and they cause heart attacks and death and all that stuff. And so we're going to start out today with the Minnesota Coronary experiment. Now, this trial is touted by... Let me share this. This is touted by the likes of Paul Saladino. He really likes this one. And another one, Ken Berry. He tends to like this one as well. And they like it because it had a lot of people in the trial, and they like to say that it was, out of all of the studies that we have on seed oils and all these outcomes, this is the most controlled for. Yada yada yada. And
Yeah.
so it mainly came to the forefront because of a reanalysis that was done. We're going to look at that as well. And so I have the original Minnesota coronary experiment right here, which no one will show you online. And maybe that's for good reason, right? So what
Right.
everybody likes to cite is the reanalysis done by Christopher Ramsden
Right.
and his colleagues some number of years ago. And we'll get into that. So what was this trial? Minnesota Coronary Survey. So this was a survey that was done in a couple of hospitals, right? So there's a mental hospital, and I think there was, I don't want to get it wrong. It's
A
in here
nursing home.
somewhere.
Was it a nursing
Yeah,
home?
no. Maybe it was a nursing home. Maybe it's something similar to that. It's in here for anybody who wants to know. But anyways, it's institutionalized people, so they're basically in a hospital setting, so to speak. So they're all of their food, not all of it actually, but they have a cafeteria. That's where they're going to get their food. And so the trial was to change the food from the cafeteria, and so you randomize people to get either the control diet or the intervention diet. And this was in here. You go 6 Minnesota state mental hospitals and 1 nursing home. So with the intervention diet, what they had was a 38% fat diet. And now Ansel Keys was part of this, and people like to say Ansel Keys promoted a low-fat diet. However, the intervention diet here is not low fat, right? 38% is not low
Right.
fat. All right. But what they tried to do was reduce the amount of saturated fat and increase the amount of polyunsaturated fat, with the hypothesis that that would lower serum cholesterol levels and would have an impact on basically heart attacks, sudden death, and all-cause mortality. They were looking at those things in particular. So what we have here, the mean duration on the diet was 384 days, so about 1 year. All right. There was only 1,568 people who stayed on the diet for over 2 years. Okay. So all in total, there's about 9,000 people. You got 4,393 men, 4,664 women. So about 9,000 in total, but only 1,570 made it, were on the diet for over 2 years. All right. So getting into some of the stuff. So the diet that they tried to, what's the word I'm looking for here? Recreate, is from the National Diet Heart Study that was involved a few years prior to this. And so they had a target of 45% of calories from fat, All right. They had a polyunsaturated to saturated ratio of 2.5 target and a target of daily cholesterol less than 150 milligrams. So as we'll get down here, we can see that the specified amounts here, so total fat 45%, and we can see they achieved about 38%. So they did not achieve the total amount of fat that they wanted to get. As far as
Mm-hmm.
saturated fat, they were over on saturated fat. As far as the target for polyunsaturated fats, they didn't meet that either. They exceeded their target for cholesterol, and they did not really even come close to their polyunsaturated to saturated fat ratio target. All right, so
Right.
point number one here on the Minnesota coronary experiment, they had targets for this dietary fat intervention that they did not meet. Right? So coming down, we're going to look at who our participants are. So remember, these are institutionalized people. These are mental hospitals and a nursing home. And the first thing that we see here, stratifying by age and sex, is that we see that the age under 30 has the largest portion of participants in it. And then next is over 70. The category of age for over 70 has the next largest number of participants in there. And then everything else in between is a little bit smaller. All right. So why is that important? Well, that's important because when we look at the outcomes, heart attacks and sudden deaths, what we find here is that the vast majority of heart attacks and sudden deaths happened within the first year.
Go figure.
Go figure. When we have a large population of individuals, let's just say over 65, because that's in the Ramsden analysis, large population of people over 65 years of age, and the majority of the deaths in this trial happen within the first year. Now, talking about hypotheses, I don't even think it's realistic to hypothesize that changing the fat amount and the constitution of fat within someone's diet is going to cause heart attacks and deaths within a year. That's unrealistic, right? And we can see that
Absolutely.
as the years progress, the number of heart attacks and deaths decrease. All right. So average length of each hospital stay was 292 days. Now, what we didn't cover here yet, and I don't think I highlighted it, was that their power calculations, when they said we need to know how many people we need to have in this trial and how long of an intervention this needs to be to actually see some effect. So they calculated that it would be somewhere between like 2,500 people and 11,000 people. So the total they had was around 9,000. But again, those 9,000 people, the average length of the diet was 386 days, about a year, right? So
Yep.
they did not meet the target time. They wanted 5 years, right? 4.6 years or
Yep.
4.5 years, four and a half year trial. And they couldn't get that. So all of the data that they have to produce any statistical analysis is underpowered. All right. And then the other problem we have here, the total time in hospital for each participant, including multiple admissions, was 304 days. So what that means is that people during this trial, this 384 days where they were in the hospital, they were actually coming and going. They were in and out of the hospital. They weren't there for a year total. One
So
continuous
yeah,
stay.
so you don't have a so you don't have you actually don't have
We don't
complete
have
control over their
control.
diet.
Right.
Another thing you don't have control of is, like, I just want to mention this a minute ago. For some of you that may have glossed over the concept about, they got like almost 1,200 people there that are over the age of 70, and plus they're coming and going. But those folks, they've whatever heart damage they've got going on, or whatever cardiac, you know, what's the word I'm looking for?
Yes.
Atherosclerosis. They've already got atherosclerosis going on.
Put a pin in that
So
and save it for later.
Yeah. Okay. Just wanted to throw that out there.
Yep.
Got
Yeah.
it.
Good point. Put a pin in that.
I pinned it.
All right. Diet and cardiovascular risk. And again, this is all deaths that happened in the trial. And again, all the vast majority of deaths, the overwhelming proportion of deaths happened within the first year, less than 1 year. Right. And even you can combine all of the deaths that happened in the next 4 years. It doesn't even come close to the total number of deaths that happened within the first year. So the first problem that we have, right, they weren't able to meet their dietary targets. The second problem is that the length of time that people were on the diet doesn't meet their own criteria for being able to achieve statistical significance. They're underpowered.
Right.
And then the third problem that we have is everyone's dying within the first year. We have all of these, very old people who are institutionalized. They're in a hospital setting. They are sick.
Yeah. They're there for a
Right?
reason.
They're there for a reason. So they're dying. All right. So what we do have here, coming down to the end of this thing, we have this little graph, table 6 here, trends in persons on diets more than 2 years. Now, if you read the Ramsden analysis, we're going to go into that next, and you come away thinking that the Minnesota coronary experiment proves that seed oils or linoleic acid specifically is causing heart attacks and death in the people in this trial, then it would be fair to assume that the longer a person was on the intervention diet, that the worse the outcomes should be. Right?
Mm-hmm.
If the intervention is causing the heart attacks and deaths, what do we actually see here? So people who were on the diet for more than 2 years, we actually see better outcomes. So let's just look at the all deaths here. All right. So ages 35 to 39, not too much of a difference. 5.4 deaths in the treatment, 7 in the control group. That's for men. For women in the treatment group, we do have higher 9.8 and 6.6. So this is ages 35 to 39. So something weird is going on with the women here in this control group, right? 45 to 55 years, which is the time that we start to be concerned about people having heart attacks and dying from them, right?
Right.
So in the treatment group for men, 6 deaths. In the control group, 11. Almost double the number of deaths. In the women, we have 4 deaths. In the control group, 14. That's almost 3 times the amount of deaths. So the longer these people stayed on the intervention diet, actually, the better the outcomes were.
Mm-hmm. Yep.
All right. And they cover that right here in the discussion, table 6. People who are on the diet for at least 2 years in the age groups chosen for recent drugs. Some show favorable trends, but the numbers are far too small to achieve statistical significance. And so again, so this was about 1,500 people. The people that were on this for 2 years is 1568 or something like that. All right. So Minnesota coronary experiment, the original trial here, we have several issues with not being able to meet targets for the diet. A large percent of the population is at an age and a health status where we would expect them to be dying at a larger rate.
Right.
And we have data on people who are on the diet the longest, and their outcomes actually improved over the control diet. All right.
Right.
So let's switch over to not Safari. I think it's this one. Let's switch over to this reanalysis by Christopher Ramsden. And so this made a big deal because the Minnesota coronary experiment was supposedly hidden. They didn't want everybody to know this data because it doesn't support the diet heart hypothesis, yada, yada, yada. And Christopher Ramsden, their group, found some undisclosed information. That's where this reanalysis is coming from. So let's quickly go through this. All right, so everybody takes away from the conclusion on this paper. Available evidence from randomized control trials shows the replacement of saturated fat in the diet with linoleic acid effectively lowers serum cholesterol, but does not support the hypothesis that this translates to a lower risk of death from coronary heart disease or all causes. Findings from Minnesota coronary experiment add to growing evidence that incomplete publication has contributed to overestimation of the benefits of replacing saturated fat with vegetable oils rich in linoleic acid. So that's the thing everybody likes to tout here. Now, they recognize in here that in the Minnesota coronary experiment, the original authors had to predict that between 2,500 and 11,645 participants would be required to obtain a difference in 5 years significant at the 95% confidence interval. Okay, so they're already acknowledging that the study is underpowered. All right, and what they went ahead and did is they removed all of those people who had died in the first year, which is pretty convenient to do, right?
Right. Let's just wipe that away.
Let's just get rid of that. If you don't count all if you don't count all the people who died, everybody lived. So what they came up with after they removed all those people from the first year was the estimated duration of the experiment required to assess the efficacy of the intervention was 3.6 years. They still are underpowered. Even if you remove all of those, right, it's still underpowered.
Yeah.
So they talk about the control diet, and that's that diet that we went over. We're going to talk about that. So predictions of serum cholesterol changes based on the Keyes equation. Now remember, Ansel Keys was involved in this Minnesota coronary experiment. And so if we look at the intervention diet and what we predicted serum cholesterol change to be would be a reduction in 18%. However, what was achieved was a reduction of 14%. So according to the Keyes equation, they did not meet the predicted serum change in cholesterol, which means something in the diet confounded that. All right? Let's put a pin in that.
I completely agree.
All right. And then they go on to talk here about the investigators hypothesized the clinical effects of lowering serum would take substantial time to manifest and thus place special emphasis on the subgroup of participants exposed to the study diets for a year or more. They actually placed special interest on the study group participants for 2 years or more. That's where we had table 6. There just wasn't enough of them to find any, effective statistical significance on this. And so what Christopher Ramsden and them want to do here is just totally ignore that table, right?
Yeah.
And so we can see between them, the randomization between the intervention and control groups was really well done, okay, which speaks to the level of the study design. They did a good job randomizing stuff. All right. These life table graphs confirm there was no mortality benefit in the full Minnesota coronary experiment cohort. And we agree on that because most of the people died within the first year. Moreover, the life table for the cohort aged over 65 suggests the possibility of an increased risk of death for the intervention group compared with the controls. In the thesis, they're talking about another paper where they got this undisclosed information that's never been seen before. Bross noted the excess mortality in the diet group seems to have been confined primarily to patients 65 or older. In the absence of the raw data, however, we cannot determine the statistical significance of this finding. Okay, fine. Let's just take that at face value. Let's say that the risk was higher in the group 65 or older. I wonder, Dwayne, what is the life expectancy of people between the years of 1965 and 1970?
Life expectancy, I think, is what, 74?
75? 70.
Ah, that's right.
70. Yeah. So it's not even unexpected during this point in time that people would be dying at this age. Absolutely preposterous. Oh, you can't see my Statista graph. Let me just do my desktop. Here we go. Statista. Right? 1965, life expectancy is 70.11 years. 1970 life expectancy is
Wow.
70.36. So it's people are dying at the expected age.
Right. Right. Wow. Let's
It's
tag that with
it's not even unexpected. Okay. So what did their analysis here come up with? There was a robust association between decreasing serum cholesterol and increased risk of death, and this association did not differ between the intervention and control group. So everyone likes to cite that there was this, for every 30 milligram decrease in serum cholesterol, there was a 22% higher risk of death from any cause. Now, people will try to run away with that and say that that was only in the intervention group. However, it didn't differ between the two groups. So whatever is causing this increased risk for, the decrease in cholesterol has nothing to do with the diet. Absolutely nothing, because the two groups were different in diets and the fats that they were eating and the amount of fat that they were consuming, and yet the risk was the same between both groups.
what's that next paragraph say? The higher risk of something
Higher risk
or
of
below there?
death. Higher risk of death associated with decreased serum cholesterol seems to be driven by the subgroup aged over 65. Gee, I wonder why.
Wow.
Is it because
Yeah.
people were, yeah. Among participants who were older than 65 at baseline, a 30 milligram decrease in serum cholesterol was associated with a 35% higher risk of death. Among people under the age of 65, there was no relationship between the change in serum cholesterol and death because people were dying over the age of 65, right?
Right.
Right. Okay.
Right.
And then they say this finding, the greater lowering of serum cholesterol was associated with higher rather than a lower risk of death in the MCE does not provide support for the traditional diet heart hypothesis. People want to run away with this. Now, Dwayne, we put a pin in what you were talking about with the amount of time spent up to this time where they introduced this diet. Right. So the traditional
Right.
diet heart hypothesis is not that you can do whatever you want until
Right.
you're 70 years old, and then all we have to do is change you to vegetable oils and get your serum cholesterol levels down, and then everything's going to be hunky dory. That is not the traditional diet heart hypothesis. It is that the exposure, the cumulative exposure to
Right.
serum cholesterol, we now know that it's ApoB, apolipoprotein B. But back then, the hypothesis was just cholesterol, right?
Right.
Cumulative exposure, lifetime exposures to high levels of cholesterol is what leads to coronary disease and
Absolutely.
death from those things. So this sentence that they have here, that this doesn't provide support, it doesn't even interact with the traditional diet heart hypothesis. This
Right.
is just a
Right.
straw
Absolutely.
man for what the diet heart hypothesis is.
Absolutely.
All right.
Absolutely.
So they go on to say participants in the intervention group did not have less coronary atherosclerosis or aortic atherosclerosis. Well, I'm not even sure why we would expect them to have less just being on a diet for 1 year. Because again, it's
Right.
cumulative lifetime exposure, right? So all the people in the hospital could have had the same amount of serum cholesterol their whole lives, which would have resulted in the same amount of atherosclerotic plaque. It's not
Yes.
even
Yes. Yes.
unexpected.
Yes.
We would expect that, right? They talk
This isn't
about,
rocket
yeah, go ahead.
science. It's not
Right.
rocket science. Jeez.
Yeah. And let's see. Yeah. So they go on to talk about the discussion here for a little bit of stuff. These changes were consistent with the predictions based on the Keyes equation and the chemical analysis of study foods. Actually, they were not. Right. So they go on to say that strengths of the intervention effectively lowered serum cholesterol and that change was consistent with predictions. It wasn't. They did not achieve the predicted change in serum cholesterol. It
Right.
was not. They showed that
Yeah.
in this paper. It's their own work. Right. So they're basically,
Yeah. Right.
lying about
Lying.
it. Right. And
Yeah.
and they go on to say here, the analysis of the association between serum cholesterol and deaths is observational in nature. So people want to say that randomized control trial, they love the Minnesota coronary experiment because the randomized control trial has the largest number of participants, the most well controlled, and the only way we can know cause and effect, they even say that in this paper, the only way we can know cause and effect is by having a randomized control trial. However, the association we see in this trial between serum cholesterol and death is just observational. You can't establish, they even acknowledge it. Therefore, it's not possible to examine causality or to disentangle changes in serum cholesterol because of diet from changes from other factors. Now, the predicted change in serum cholesterol based on the Keyes equation was not achieved, which tells us something confounded that change, right? Now, in the trial, they used corn oil and they also used hydrogenated vegetable oil products. Would have been corn oil. Most of it was corn oil, which would have been hard margarines. They use soft margarines. These things would have been partially hydrogenated because that's what they did at the time. And partial hydrogenation, we now know, raises the level of trans fats in those foods. That's why partial hydrogenated, shortenings and margarines and stuff are banned. We banned partial hydrogenation in 2018 because of the amount of trans fats it puts in. So they say because the trans fatty acid content of MCE study diets are not available, one could speculate that the lack of benefit in the intervention group was because of increased consumption of trans fats. Indeed, in addition to liquid corn oil, the intervention diet also contained serum cholesterol lowering soft corn oil polyunsaturated margarine, which likely contains some trans fats.
Yep.
All right.
Yep.
And they have a whole paragraph after that trying to explain away, well, this can't possibly be the case because Ansel Keys and the primary investigator were part of this diet that they tried to mimic, the National Diet Heart Feasibility Study, and that diet achieved the greatest reductions in serum cholesterol of all the NDHS study sites. That's fine that they tried to model that diet. However, based on this reanalysis, Christopher Ramsden at the beginning, they show what was achieved. We also looked at what was achieved in the Minnesota coronary experiment. They did not achieve that diet. It's fine that they modeled after it. They did not achieve it, right? And we can't even go to that study. And what happened in that study? Well, let's just look at male subjects between 40 and 59 years of age ingesting foods low in saturated fat and relatively high in polyunsaturated oil sustained a 14% reduction in coronary artery disease as compared with subjects on a control diet. So we know they didn't achieve that diet, number one, because their own dietary analysis shows they didn't achieve that diet. Number two, Christopher Ramsden and them are acknowledging, yeah, there probably was some trans fats in this diet. And number three, we know that the outcomes weren't the same. So that you can't try to explain away, well, this can't possibly be trans fat because they tried to model the diet after this other diet. Well, you can try and do something all you want. Did you achieve that? The answer is no. They also try to go on to say that that Keyes and France were well aware of the cholesterol raising effects of trans fatty acids. And that's also fine, but it still doesn't interact with them. They can be perfectly aware of the cholesterol raising effects and try to mitigate that. However, it just wasn't achieved. What we also did not know at the time, so they knew trans fats raise cholesterol, but we also did not know how much of a negative health consequence trans fats were. They did not have that information. All right. So finally, without additional recovery of MCE data, we are not able to determine if the effects of the high linoleic acid diet varied by smoking status, pre-existing coronary artery disease, psychiatric history, or drug use. So there's a whole bunch of possible confounding factors that could explain away why we see the deaths in certain groups and not in others. All right. Last but not least, they did a meta-analysis here. They combined some other trials that we're going to be looking at in the coming weeks. And let's take a look here. Dwayne, we have the MCE, linoleic acid right here. What is our confidence interval doing?
Oh, way below the line, above and way below the line. It's just,
Crossing the null line, right?
it's absolutely, absolutely.
So our confidence intervals range from 0.78 to 1.62. These are extremely wide confidence intervals. It also crosses the null line. So the overall effect that this study produced is a null association. They are acknowledging in their own meta-analysis that there is a very real possibility that the deaths explained in this can be attributed to just random chance.
Yeah, those aren't very just the width of the confidence level is like there's too that's too big of a range to be able to speak about something like that with confidence, actually.
With
It's just
confidence,
kind of
it's
remarkable, kind of
yeah,
remarkable.
it's very
I
wide
just don't
and it's null.
no, absolutely. So one of the things I was just thinking about is we keep talking about the control group. Okay, so a lot of this is flawed from the beginning because you don't really have a control group. You stated that people would come in and out of the hospital, right?
Mm-hmm.
Those people when they come in and out of the hospital, you
Yep.
don't have control of what they eat when they leave.
Yep.
You don't have control of what they're doing when they leave. And based on their ages, we don't know if they were smokers. We don't know what other kind of health issues they had, what their atherosclerosis status was of their cardiac system. We don't know. Maybe they went home and they were wild drinkers, or maybe they just went home and ate tons of pizza. We don't know any of that.
Yeah.
So it's not really a control group.
Right.
Boom. You
That's
don't
a
have
yeah,
that.
a very astute observation. And they even acknowledge, I think Ramsden and them acknowledge, or maybe it's in the original paper. So the way they assessed compliance with the diet was basically punch cards. So when you went to the cafeteria and you got your lunch, you were given a number basically, and so you gave the number to the cafeteria, and then based on that number they either gave you diet A or diet B, and you had your little cards punched, and that's how they attributed compliance, or they figured out compliance. And so they acknowledge in there, they're like, when we see people who have lower rates of compliance, we just can assume that they're eating their food somewhere else. So even though these people are in institutionalized, they're free to come and go, and there are times when they're not eating at the cafeteria, they're eating somewhere else. They're eating something, right?
Yep.
So
Yep. Absolutely.
that's another reason why we don't see the predicted serum change based on the Keys equation actually panning out. As they're just eating other places, so there's all kinds of confounding things in this trial. So even looking at the reanalysis, the original trial, I don't think, if you're walking away from this thinking, oh, well, this definitely shows seed oils are bad for you, you're insane.
Yeah. And make
Sorry.
no bones about it. There are people they're going to say they're going to quote this. They're going to point to this to the reanalysis as well as the original, and they're going to draw their conclusion on that. They're going to say, "Well, this is what it says."
Hmm.
No, it doesn't. It
Nope.
just really doesn't.
It
I mean,
doesn't. There's too many confounding factors. It just wasn't long enough. The outcomes that we looked at when we look at a whole bunch of other factors, that what was the life expectancy during that time, the how many people were in the oldest age group, and all this, like the outcomes actually aren't even unexpected.
yeah, yeah, yeah,
We can explain these outcomes just based on
yeah,
looking at these other things. So there's a reason that this trial was put in a drawer and filed away somewhere, is because we just can't learn anything from it.
yeah,
It's not very good data. It was, the design overall could have been better. It was okay, but the way it was executed was poorly done. And there's just not a lot that we can take from this. It also doesn't show that seed oils are fine for you. It doesn't show that. It just doesn't
yeah,
show anything, right? There's
yeah.
just too much going on, too much happening there.
So, I want to say one more thing is that it dawned on me just a few minutes ago that there are people out there that might be listening to us or watching us. And as our viewer base grows, it dawned on me that some people think that we try to debunk everything that comes out, or we try
Mm.
to tear up every study that comes out. There are studies that we've looked at that are done well and
Hmm.
have excellent conclusions, whether we like them or not. But
Yeah,
this isn't
exactly right.
this isn't one of them.
Yeah, I've had to change several of my own personal beliefs based on. See, I did
As
not
have
want the
I.
things to be true.
As have I.
However,
As
we
have
looked
I.
at stuff and is like, man, this thing's robust, and you know,
Yeah. Yeah.
you, you can't try to rationalize or justify, you know, weird things happening within because it doesn't fit your hypothesis, because it doesn't fit your worldview. You need to change your bias or your worldview based on what the data is telling you.
Yeah. Yeah. Yeah.
All right, man. So that's the Minnesota coronary experiment. And yeah, so anytime you see somebody online touting the Minnesota coronary experiment, it's probably going to be very obvious to you now that they haven't actually read it.
I would venture to say most people haven't read it.
Yeah, most
Like
people have not.
high 90%. High 90% haven't
Yeah,
read
they probably have
they're,
not.
They're just taking what they've been told on television.
Yeah. All right, man. That's it. Hope you guys got something out of this. Hope some minds were blown, and we will catch you all next time. Coach Lambie and Dwayne out.